You know, when we look up at the night sky, it seems so peaceful, right? A vast, silent, beautiful void. But that is one of the grandest illusions there is. The universe is actually home to some of the most violent, most destructive environments you can possibly imagine. We're talking about places where the laws of physics themselves become a death sentence. And today, we're going to run that cosmic gauntlet.
And this quote, it really gets to the heart of it. This isn't like the movies, you know? It's not about fighting aliens or dodging asteroids. This is about fundamental physics creating conditions so unbelievably hostile that for any piece of technology we could ever dream of building, survival isn't just hard, it's completely, utterly impossible. So that's the big question for today. What does happen? We're going to put our theoretical spaceship through three distinct challenges, three different ways the cosmos can just unmake anything we build. First up, we're facing the oldest and most relentless force of them all. Our first stop on this tour of cosmic horror is gravity. And I'm not talking about the gentle pull that keeps our feet on the ground. Oh no. We're talking about gravity cranked up to its most tyrannical, its most destructive setting, a level where it doesn't just pull you in, it literally rips you apart. And that process has a name that is just fantastically, horribly descriptive: spaghettification. It's exactly what it sounds like. It's what happens when the gravitational pull on one end of an object is so much stronger than on the other that it gets stretched and stretched and stretched into a long, thin strand of cosmic spaghetti. Let's put this into perspective. Here on Earth, if you have a spaceship, the difference in gravity's pull between the nose and the tail is, well, it's basically zero. You'd never notice it. But get close to a black hole, the front of that same ship is being pulled with millions of times more force than the back. There is no material we can even conceive of that could withstand that kind of strain. It would just come apart. We're talking about a gravitational gradient, a difference in force that can be more than 10,000 Gs for every single meter of your ship's length. That means every meter is being pulled apart with a force that would cause instant, catastrophic failure. You wouldn't even have time to register what was happening. It would be over in microseconds. And hey, this isn't just a black hole problem. When two neutron stars, these incredibly dense remnants of dead stars, collide, the tidal forces are so insane they shred the stars themselves. They tear apart matter at a nuclear level, flinging it out into space and forging heavy elements like gold and platinum in the process. So gravity at this scale, it's both a creator and the ultimate shredder. All right, so let's say you somehow, magically, survive the tidal forces of gravity. Well, the universe has plenty of other tricks up its sleeve. The next challenge isn't about being torn apart by force. It's about being flat out annihilated by pure, overwhelming energy. So what is this number? That is the magnetic field of something called a magnetar. For comparison, that's about a quadrillion times stronger than the magnetic field of Earth. A field that powerful doesn't just mess with a compass. From thousands of kilometers away, it literally rewrites chemistry. It would warp the atoms in your ship's hull, break their bonds, and vaporize the whole thing from the inside out. Next up, a supernova. That number you see, that's the amount of energy our own sun will produce over its entire 10 billion year lifespan. A supernova unleashes all of that in a few seconds. It's a wave of radiation and a shock wave so powerful, it wouldn't just destroy a spaceship, it would erase every trace of it from existence. And what about this? 10 million degrees Celsius. That's the temperature of the accretion disk around a black hole. See, it's not the black hole itself that's the immediate problem. It's this swirling vortex of plasma, hotter than the core of our sun, that's screaming into the abyss. It blasts out so much X-ray and gamma radiation that any shielding you could possibly build would be useless. So you've got all these different ways to be vaporized, right? The magnetar uses magnetism to basically cook your ship from the inside out. The supernova hits you with a blast wave of radiation that shreds you to atomic vapor. And then there are relativistic jets, beams of particles shot out from black holes at nearly the speed of light. Flying into one of those would be like getting hit by a cosmic sandblaster that just disintegrates matter on contact. Okay, so we've survived being ripped apart by gravity, and we've survived being vaporized by pure energy. But our final challenge comes from something, well, something a lot more ordinary. Just running into stuff, whether it's on a massive scale or a microscopic one. Just picture it for a second. Imagine a sleek ship gracefully gliding through the absolutely beautiful, iconic rings of Saturn. It's serene, it's majestic, It's pretty much the dream of every space explorer, right? Yeah, the reality, that mission would last less than a second. That beautiful, serene vista is actually a hypervelocity minefield. The rings are made of billions of bits of ice and rock, from tiny dust grains to huge boulders, all whipping around the planet at tens of thousands of kilometers per hour. A ship flying through that wouldn't just be damaged, it would be shredded by a constant barrage of impacts in less time than it takes to blink.
But getting obliterated by stuff isn't always about fast impacts. It can also be a slow, crushing, methodical process. Imagine, instead, plunging deep into the atmosphere of a gas giant like Jupiter. There, the weapon isn't rock or ice. It's the air itself. A descent into Jupiter is basically a multi-stage nightmare. First, your ship gets instantly crushed by atmospheric pressures thousands of times greater than the bottom of our deepest oceans. Then, whatever's left of the hull gets melted by temperatures that skyrocket to tens of thousands of degrees. And finally, the mangled molten wreck is ripped to shreds by supersonic turbulence and winds. Crushed, melted, and torn apart. Game over. So, after running this little cosmic gauntlet, what's the takeaway? I think the sheer, overwhelming violence of these places tells us something really profound about our own fragile place in the universe.
And here's the crucial point. The destruction we've been talking about, it's not because our hypothetical ship has an engineering flaw. It's because the fundamental forces of the universe, gravity, electromagnetism, the nuclear forces, are operating at their absolute terrifying extremes. They create conditions where the very bonds holding matter together just give up. Our technology is fragile in these places because, at these scales, matter itself is fragile. And that really leaves us with one last kind of awe-inspiring thought. These cosmic crucibles, these unbelievably destructive places, they're also nature's ultimate laboratories. They are where matter is pushed to its breaking point and completely unmade. So if we want to understand how our universe was made, how all this stuff came to be in the first place, maybe the best place to look is at the very places where it all comes apart.